see the answers.
It's just numerical answer.
Okay, so answers for aggregative or particulate fluidization. Please, you need to mention this one is usually for what system. So for example, this one is for gas solid system. Okay, then where the uniform behavior will be only observed at low velocity, but for high velocities, there will be two separate phases can be formed. So you need to mention two important things, usually for gas solid and then high velocity. Two phases. Okay? Okay, evaporation. Evaporation is a process where the vapor from a boiling liquid solution is removed and more concentrated solution remains. Okay? Alright, then for the few particular function, what is the for this type of questions, you just refer to your lecture notes. All the answers will be there. Okay? Part B, for the different types of valves, try to choose the proper valve for the particular function. Okay? Any questions here? Try to relate the question to the most relevant one. I cannot test you exactly the same question, right? So, for example, I test you aggregative fluidization already last year. So this year, I will test you particulate fluidization, or I just ask you what is the definition of fluidization. It's possible. Okay? I cannot test you exactly the same. Alright, then, can we move on? Okay, now, move on now. Can? Okay.
last year? 18, 19 ah?
Okay, for A2. Okay, everybody, for A2, this is a typical question for fluidization. So the calculation questions will be more or less similar to this. Please practice. Okay, so this is for fluidization. You see here what is given. A diameter of the particle is given. Then the air condition is given. Please take note. You learned the air property will be affected by pressure, right? So now the pressure given is 1 atm. If I give you 2 atm, do you know how to do it? How to find the density? How? Density is proportional directly to pressure, right? Just try to recall us. Okay, so usually for air table, if you check the air table, you can only find the density at 1 atm, if it's 1 atm, right? But if I give you 2 atm, so it means the density will be doubled. Okay? Density will be doubled, right? Okay? you just read the question carefully lah. So now it happens, what is given is 1 atm, 30 degrees Celsius. You can directly check from the air table. Okay? Then you can find the density of air. Then the density of particle is given. The void fraction at minimum fluidization condition. What is this? The void fraction means the porosity. We have another name, porosity or void fraction. So this one is an epsilon. We write either epsilon or E, MF, minimum fluidization. The bed diameter is given 0.7 meter, and the solid mass of solid is given. Okay? So now you need to calculate what is the minimum height, then calculate the minimum velocity, then list down 3 applications. Alright? Now let's see. Please take note, I need to highlight this again. This is the default condition. Highlight. This is the default condition which is not given in the question, but you need to use it in order to find the minimum void fraction at minimum fluidization condition. What you need a default condition. Default condition means this: porosity equals to 0 means no pores inside the column. So it means if you add all particles, the total volume of particles will equal to the volume of the column. Are you all following this? This one you have to memorize, everybody. So it means this. So it means you need, when you write this side, the mass over, this side, mass over density actually is the volume of all particles, correct? Okay? Then the other side is the height times the cross-sectional area is actually the volume of the column. So when these two equal to each other, means porosity will be 0. Okay? So that you will apply this later. See here, you have a porosity equals to 0. The height is this one, right? Okay. So otherwise, you cannot find the minimum fluidization height. You need one height, the default height, to find the minimum height. Any questions here? So this one I highlighted many times already. Okay. Then everybody okay for this part? Yeah, can we move on? Second part, for this, please take note. For this one, the equation will be given. You don't create another one. Please follow properly. Just need to substitute all the values correctly inside. Please take note, you have something here, square. Okay? Then this is the density of particle minus the density of air, right? And one more thing is, here you have a square root. Don't forget. It's only the calculation part, you just need to be careful. Okay? Common sense, please take note. This term actually after square root should be very close to this. Should be 33.7, very close to this value. So that you can see here, the real number very small. Okay? Then this real number should equal to this real number. We let them equal to each other. Many of you, common mistake, listen, common mistake viscosity of air, you forget this minus 5. If you check the air table, you will need to find this factor here, the index here, -5. Don't forget, okay? And also, here you have a square. Here. So this very small value here you have a square. So when you calculate this, you must be calculate very carefully. Okay? So finally, your minimal fluidization velocity equals to 0.00477. Okay? So it's very small. Common sense. Minimum fluidization velocity will be very small. Okay? Because that is the velocity to push the particle to move only. Cannot be very high. You all okay with this? Can don't forget, if let's say just now I say here, right? The pressure, if the pressure is not 1, the density will be proportional, but viscosity will not change. So viscosity will be the same as 1 atm. Okay? Okay, let's move on. Are you okay? For fluidization, listen. There's another one, although it's not in this paper. In the revision, I already mentioned, which is quite important. Fluidization curve. How to plot? Fluidization curve. This is the velocity, and this is the pressure drop, right? You will have 3 periods or 3 stages, remember? Okay, then what are the names? What are the names? So at the very beginning, the pressure will increase when the velocity increases, right? So this is the fixed bed. Once the velocity reach to minimum fluidization velocity, the pressure will keep constant. We call this fluidized bed, right? Then finally, you have another point, which is the terminal velocity. So this is called pneumatic transport. Okay, so usually the fluidization will be this 2 period only. You cannot see this part. Okay. I will try to link all the relevant knowledge here, important points here. Okay. All right. So the last part is 3 applications. You can just give some examples, especially the application for the petrochemical industries, or can be even for heat sensitive materials, can be food products. So this is the A2. Let's move on. Okay, next one. A3, it looks like very strange shape here of the pipe. Does it matter? No need to worry about this. You see, you have A, B, and C, right? Actually, the B doesn't matter one. Okay? You know the diameter of A, then anyway, what equation you should apply here? The question asks you to find the velocity in C and flow pattern. What does it mean by flow pattern? Yes, you need to calculate Reynolds number to tell the flow is laminar, transition, or turbulent, right? Okay, so which equation you should apply? Continuity equation, yes. Okay? So actually it doesn't matter, although you don't know the B, but A should equal to C, right? Mass flow rate. Okay? So try to apply the continuity equation. So anyway, mass flow rate in A should equal to mass flow rate in C. Right? Yes? Okay, mass flow rate in A should equal to C. Then for liquid, listen, for liquid is incompressible fluid, right? So density will be constant. So you will cancel out the density, then will be A times B only. Okay? So you can see here, velocity in the C should be lower or higher? Lower or higher? Because the pipe is bigger, right? So the velocity must be lower. Then calculate Reynolds number. Then you see, please memorize the two values are 2,100 and 4,000, right? If below 2,100 is laminar, above 4,000 will be turbulent. These two values, please memorize. Okay. Then the B, I no need to explain. This is a drawing question. It's not covered this time. Actually, you are very lucky. Tell you, the drawing part is very complicated. Yeah, this time we cut out. You don't have this part already. Is it okay? Not ready? Any questions? Any questions? Let me see whether we have any. Hold on. Okay, listen. Please take note. There's one important point here I have to highlight. See, the viscosity is 1 cp. 1 cp equals to how many Pascal second? You have to convert, right? Yes. So that's why we even give you 1 mark here for the unit conversion. You use this. See, 1 cp equals to 10 to the power of minus 3 Pascal times second. Okay? Please, once you see cp, quickly convert. You will see this. Yes. Correct. Density here, you should use the value 996, which is given. Here. Correct. Your answer is still the same. Thank you. Okay, can we move on? All right. Now, next, A4 is a filtration question. Usually for filtration question, we will cover 2 parts. Some theory, some calculations. We will not test you plotting the graphical method I told you already, because you got no time to plot. Okay? We will test you similar. We will give you an equation. From there, you should identify what is KP, what is B. Theoretical question. The main factors affecting filtration rate. Then you also learn how to select a proper filter medium, right? Whether it's filter paper or filter cloth, or what is the main function of filter aids. Okay, so these are the theoretical questions we may ask you. Then here, similar. This is a plate and frame filter press. please, you need to read your question carefully. In this question, the area is given directly, 400 cm squared, okay? But if let's say I give you per frame, just like in your practical, per frame, the area is 400. Total, you have 8 pieces, just like in your practical. Then you have to times 8, right? And also the cm squared, you have to convert to meter squared, yes. And 1.2 bar, you have to convert to Pascal, kilopascal. See later. Okay, so the equation is given already. You need to find the time. And then, second part, if the filtration area is increased by 2.5 times, so means the area is 2.5 times your original area, right? How long it will take to filtrate the same amount? Okay? Okay, so the first part is very straightforward. Just ask you to calculate the time only, so you can directly substitute inside here. And the main factors, any 4 factors here. Are you okay? Okay, for the second part, you need to calculate once you see there's a change in the filtration area, so means you have to find out the new values of Kp and B. Okay? So try to identify from the original equation what is Kp, what is B. Alright? Don't forget, this is Kp over 2. This is a very common mistake. Some of you may forget this. This is Kp over 2. From here you find Kp1. Okay? B1 is here directly. Then this ratio I mentioned already during my revision. During my last revision, I already mentioned you have to know this. How to get here and how to get here. Okay? Don't write wrongly. It's a reverse. Please. This is Kp2 over 1, but here is A1 over A2 squared. Okay? Okay, so after you find the new Kp and the B, then you substitute inside. Then you can calculate the new filtration time needed. Don't forget, here, this one must be, this is the filtrate volume. You must convert liter into meter cube. Don't forget. You need to convert the units. Okay? Any questions? You see, this question and just now, the fluidization question are all standard one. You follow this way, actually you should get the full marks for this type of question. Right? It's not difficult. If the question never asks you the time must be in minutes, you can show your answer in seconds. Doesn't matter what. Okay? questions? Please, you need to know how to show these two equations. Okay? Okay, let's move on. So this is the A4. A5 is an evaporation question. But you see here, we already gave you the necessary two equations. You no need to memorize these two already. Okay? But please take note. The changes is from here 0.6 to 1.5. Is it dilute solution? Can consider the same as water?
Yes.
Yes. Very good. Okay. So what you need is you just need to apply material balance, energy balance already given here. You need to find out all the enthalpy values inside here. Okay? Then you can, the question asks you to find what is the calculate the mass flow rate of vapor and liquid. Then calculate the heat transfer area required. Okay? Please, this diagram, you need to know how to plot. Again, we may not give you this diagram, but this is a past year's paper we give already. I need you all to know how to plot this diagram. Okay?
Sorry.
Okay, let's see how to do it. Okay, so for material balance, we need overall material balance, individual material balance. After you find L and V, please double check on your own. V plus L should equal to F. Yeah? Your F is given is 8,000, right? Okay? And then after you calculated, you should check whether this value plus this value will give you this 8,000. This is for your self-checking. Okay? Then for enthalpy calculations, please take note. Wherever you see liquid, so this one is for liquid, right? Then this one also for liquid. So once you see liquid, means you can use Cp delta T to calculate. Cp delta T, the delta T refers to your actual temperature minus 0 degree. But if you have a Kelvin, then this one should be 273. Okay? So you see here I use 273 because the 320 is in K. This one is in degrees Celsius. Okay? Either one will do. Okay? Because this one your direct reading from the steam table is in degrees Celsius, right? So if it's in degrees Celsius, minus 0. Why minus 0? Because we set 0 degree as my reference level. It's 0 enthalpy. Okay? So these are the two liquid. Then for vapor, this one is for the steam, should be the latent heat. So means you check the middle column of the steam table. Then this one is for the vapor, saturated steam table. Sometimes this reading is slightly different. It's 2676. Also okay. Then after that, you can determine what is the amount of steam. Why you need to determine this? Because you need this value here for this calculation. Please take note. You need to convert the units to kilogram per second. Okay? So this is your final answer of the area. Is it alright? Okay? And also take note, here, this temperature difference. Very important. This temperature difference is actually the steam temperature. Here, you need to check under 1.35 bar, what is the temperature? So this is your actual temperature, 108.2. And then T here is the actual temperature of the boiling inside the evaporator. Okay? Are you all okay with this? Any questions? Okay, can we move on? So for section A, there will be 5 questions. Each question is 12 marks. Okay, so total will be 60. Then section B, there will be 2 long questions. So the same, you can see here, usually the B1 will be still this type of question, friction loss. Then to find out what is the power needed for the pump. Okay? Please take note. When you read through the questions, please highlight the units like this. So for example, this one is liter per minute, right? Okay, so it means you, what is this? This is the flow rate. So means this is not the velocity. Please never use this value directly. I just tell you, no matter how many times I tell you this, there are still some of you who will use this directly. Don't use this number directly in your calculations later. Then the pipe size is given. This schedule, you need to use the pipe table to find what is the actual diameter. And also for the elbows, already given 90 degrees. For the valves, you see here, also very nicely given, wide open, right? So you should follow this. Okay, what else? Please take note. Everybody, you need to follow this. Yeah, I purposely highlight this because this sentence is very important. See here, this sentence, listen, you need to read very carefully the sentence regarding the height. This sentence will tell you later for the overall mechanical energy balance, your balance is from where to where. What are the 2 points? Okay, so see here, the height between the surface of the open tank and the surface of the bottom pressurized tank is 20 meters. So what are the 2 surfaces? So one surface is in the open tank. Please take note. The pressurized tank is below. It's not above. Okay? The pressurized tank is lower. It's already given like this. Listen, we may not give you this flow diagram. You need to know how to draw it. Okay? But this paper is so nice, we already provide you. Okay? So means later you need to do a calculation from this surface to this surface. Okay? See, once you see, some of you email me, I didn't answer y'all, I want y'all to come over here, I will answer your question. Okay, why sometimes the velocity is 0, sometimes it's not 0. In what cases you will consider to be 0, okay? See here, this surface will be later your surface 1. This surface will be your surface 2, right? So what is the flow direction? Will flow from here through the pump, then go down to the pressurized tank. Okay? One question is, you see now it's flowing from the higher one to lower one. Why do you still need a pump? Because this tank is pressurized. But if let's say you don't have a tank here, it's just open to somewhere, do you need a pump? If you don't have a tank here, we just say something flowing from a tank through the pipes, then discharge to somewhere. In that case, do you need a pump? No need. Please don't be surprised if you don't see a pump. Doesn't mean cannot flow. From higher level to lower level, if you don't have a pump, there will be still friction losses. Okay? Okay? Alright, so now please, the question is, you need to follow the flow direction. Listen. So just now I said this sentence is very critical, will tell you which one is higher, which one is lower, and where is your 2 points, right? Then after that, please follow the flow from point 1, flow down to point 2. Then on the way, please check, is there any sudden expansion? Is there any sudden contraction? Have or not? Have or don't have? See here, this part, here you have a sudden contraction. Do you have a sudden expansion? Yes. So from a pipe into a tank will be sudden expansion. So you will have this two. One more thing. What will be the velocity at this point and this point? What's the velocity? Listen. What's the velocity? Here is 0, here also 0. But it doesn't mean there will be no flowing. Okay? 0 means very low. Okay? But something is flowing inside the pipe. So you will have a velocity inside the pipe. Don't forget. Okay? So, how to do it? Standard one. Please. Step 1. Convert units of volumetric flow rate. Please convert to meter cube per second. Then calculate the velocity inside the pipe. And you need to use the pipe table to find the actual inside diameter. Because your fluid is flowing inside. Okay? Don't use wrongly. When you check the pipe table, don't use the outside diameter. You must use the inside diameter. Okay? Okay? Usually, please take note. Please take note. Usually will be turbulent flow. If you calculate, you find your Reynolds number is very small. Something wrong already. Why? Usually, if let's say you calculated, you find your Reynolds number is small, most likely will be you forget this -3 for the viscosity. Yeah, so I need to highlight this again.
I believe in.
Don't forget, -3 viscosity. So usually the Reynolds number will be quite big. Okay. Then just now we mentioned there will be a sudden contraction due to the, please write inside the bracket. Listen. Can you all please write this? Because from tank to pipe. Okay? And this one is because from pipe to tank. Otherwise, Kc may not equal to 0.55. Right? Okay?
Oh, dari table.
Okay now? velocity inside the pipe will not be given directly. You have to calculate. You need to know how to calculate velocity. This is the step 1. Okay, then for the fittings and the valves, read carefully from the table, add all. Okay, so you have 3 elbows here, you have 2, maybe these are the fittings, these 2 are for the valves, right? Okay. And then this velocity, please take note. This velocity refers to the velocity inside the pipe. Inside the pipe. Okay? Also highlight what units you will have here. What units? This is the units joules per kilogram. This will be the units for friction loss. Okay? And everybody okay? After this, so this is usually part A. You have to calculate the total friction loss. Then part B will be how to apply overall mechanical energy balance equation. So part B, you will need to do a balance between the 2 points, just now we mentioned. Okay, you need to state this. V1 equals to V2, very close to 0, almost 0. The reason is because of large cross-sectional area of the tank surface. Okay? Then we set Z2 to be 0, Z1 will be 20 meters. So means your point 2 is lower. Always set the lower position to be your 0 height. If the flowing is from low to a higher, so means your Z1 will be 0. Are you all following? Are you all following well? Yes, okay. Then also take note. Finally, here, this part. I need you all to take note. What units is needed for pressure? For pressure. Pascal. It's not kilo Pascal. Please take note. It's Pascal. Okay? So after this, you will find the WS in this unit. Then you need to multiply the mass flow rate to convert the units. So mass flow rate will be density times volumetric flow rate. So that's why at the very beginning, you better leave the volumetric flow rate value there. You will use that here. Then after this, you use this times this. This will be for the unit conversion. Okay, so this unit conversion will be joules per kilogram. You times kilogram per second will give you watts. Finally, you need to divide it by the efficiency. Okay, so means your actual power supply should be more than what you calculated. Reasonable, there will be certain loss, right? Okay, so you should give more. Alright, so WP should be higher than WS. Got it? So this is for question B1. So definitely this part will be tested again. Okay? Alright? Any questions? Any questions? Are you all okay? Can we move on? The last one, B2, is the heat transfer question. B2A asks why in certain countries there will be a double window needed, right? Okay. So in double window, there is a layer of stagnant air in between the glass. The reason is this, air, the thermal conductivity is very low. Okay? So it will be very good insulators for heat transfer. So that the layer, the stagnant layer of air will be like an insulation layer. Okay? So this is the part A. Part B. Let me see the question. Okay. So for part B, listen. Please take note. Whether it's heat resistance or we call thermal resistance, please get familiar with that term. If you are asked to find what is the thermal resistance, what is that? Means you need to find the capital R for each layer, right? Okay. So let's see here. So you will have the resistance. How to get here? Definitely we will not give you this equation directly. You remember, we will give you the one. Let's see what type of equation is given. We will give you this one. Okay? So you should know below here is your resistance. Okay? So you just apply will be here. This is your resistance. This one no need to include delta x. You can write x directly. X. Okay? Okay, so this is for the thermal resistance. You have 3 different materials. Okay? So after that, what is the total resistance, right? And then, what is the heat transfer rate? This one here, the heat is minus, why? Can we come back to the question and see what is asked? Please see here, it's mentioned, calculate the heat loss in watts. Okay? So calculate the heat loss means your value will be negative. Otherwise, you don't need to show it's negative. You can say, if let's say we just ask you what is the heat transfer rate, then you just use higher temperature minus lower temperature. But for this case, it's asked, you need to show what is the heat loss. Okay? Okay? So it's minus here, minus. Then what is the temperature at the interface between different materials? You need to find T2, T3. Okay? So this is the end already. You all okay with this? Okay? Hey, no need to worry. I already give you all answers already. You try it by yourself. Okay? Okay, So do you still want me to go through the other paper? No need already, right? Yes. Can you all try on your own? I give you all answers already. More or less similar.